Okay, so we have distances between all the cities with, so to say, main diagonal, which is this distance to yourself being always a 0. Okay, now the next thing we want to know is, and now comes in an array function, which city is the closest by. For instance, we take the first column and we want to know which city is the closest one. Well, we can see that the smallest number is number 7. This is 6.4 kilometers. But let's calculate it like this. We write equals min of this block and here comes the trouble. Namely, 6.4 kilometers is the smallest distance, but even smaller is always the distance to itself, to the first city itself, which is always 0. And here we need this array function formula, and we write it like this: equals minimum, and now we write if f4 colon f13 is bigger than 0, then semicolon f4 colon f13, then we take it itself. Otherwise, if it's not greater than 0, if it's the distance to itself, we can put down a very big number, let's say 6 nines, a very big distance. So when the distance is above 0, this very same distance is used. When the distance is 0, it's substituted for 99999, and this if, again, is an array function. It works with the entire array all at once, and it nicely substitutes those zeros for those big distances always, and we put it all inside min, and it takes the smallest element, which now will be this 6.4. But naturally, we have to enter this formula with a Control-Shift-Enter. So here we go, 6.4. Okay, now we've used index in this exercise many times. So this time let's now use match. But before, let's go over this formula one more time. So here we see it. It's the usual formula. The only thing is that if has a block in itself, which makes it an array formula, which makes us enter it with Control-Shift-Enter. And when we look at the formula up there on the formula bar, we will have curly brackets around it. And now, we know that the smallest distance is 6.4. We want to know to which city is this. Right now it's the 7th city. This we get with a very simple command, match. We will match 6.4 from here. It will give us 7, and 7th row means that it's the distance to the 7th city, which means that 7th city is the closest one to the current first city. Let's write it down like this. Equals match. We're matching the 6.4 from the block above, and with a 0 because it has to be there exactly, and enter, and here it is, 7. This is the city that is closest by. And now we will once again use index to get all the city coordinates. For instance, we want the 7th city coordinate, so we write equals index, x coordinate is the one we want, semicolon, and now take this 7 with f14, and we write another one with index y, semicolon, f14. And we take this entire formula and copy it. And as we see, second city, the closest one to the second city, is 4.4. This is the 7th city again. And 7th city will come out with this if min and this match, and this index will also bring it up, and we will have both to the first and to the second city, the closest one is 7th. But to the third city, the closest one will be, let's see, the first one. 10 kilometers is the smallest number. And if min confirms it, match takes number 1 and finds that this 10.29 is on the first row and tells us number 1. Let's take one more example. Let's take the fifth city. To the fifth city, if we look at it ourselves, the closest one is, let's see, 13, 14, 12, 8. Yeah, this 8. Which means that the closest city should be 9th city. 5th city should have 9th city as the closest one. When we do if min, it works through the entire block, substituting 0 for 9999 in the middle, and taking all the same, leaving all the other ones the same, because it's in the if the same block is used if there is no 0 as the distance. And now we take minimum from everything above 0, and we get this 8,06, just as we expected. Now we match this 8,06 from the green block above, and we get that it resides on the 9th row, and we get that the closest city to the 5th city is the 9th city. And now we use index, and take from x is the 9th x, and from y is the 9th y. Now, the next thing we want to do is, well, these drawings here for the Pythagorean theorem are no longer necessary, so let's take these aside. Okay. Namely, now Microsoft Excel graph has already been created, which shows us the results of this exercise. On this graph, what's been done is right-click, select data, and in here, add point. And what's done is that every point here has been added separately. X of city 1, sorry, let's delete it, it's the series name. X of city 1 and X of the connected city 7, holding control to fit them both. Now y values. Y of city 1 and Y of city 7 that's connected, again holding control to get them both. And now OK, and here you see that one line was added and it changed color. I'm going to undo, it here changes color, it's removed, and now this is the one we added. So this way, one by one, every combination has been added. But the reason why this painstaking effort has been undertaken is that now we see visually what our algorithm ends up with. This is something really close to the minimal spanning tree algorithm, and we have a minimal spanning tree has a really wide range of applications in computer science. And what we have is every city is connected to the city that's closest to it, forming such a, let's say, route or network of roads, or whatever we want to interpret it as.